Hello मेरे प्यारे बच्चों and welcome back. I know exams are just around the corner and the tension is building up. But fikar not. Your favorite tutor is here and you and we're going to make this chapter Gravitation so simple you'll be teaching it to your friends. Chalo, let's get started.
So, have you ever really stopped and thought about this? When Virat Kohli hits a massive six, that cricket ball flies high into the sky, but it always comes back down. An apple from a tree? It falls down, never up. Why is that? It's almost like there's an invisible string pulling everything towards the earth. And you know what? If you thought that, you're absolutely right.
All right, so here's our simple little game plan for today. We're going to start with what this super important force is. Then we'll look at Newton's big rule for it. We'll dive into something called free fall, clear up that whole mass versus weight confusion, figure out why some things float and others sink, and then we'll finish with a little power-up to get you ready for your exam. Simple, right? Let's do this.
Okay, our first stop, what exactly is this thing called gravitation? Just think of it like we said, a giant, invisible string. It's the exact same force that made the great Sir Isaac Newton look at a falling apple and go, now that's interesting. And this force isn't just an Earth thing. Oh no, it's a universal force of attraction between any two objects in the entire universe. It's kind of like the cosmic glue that keeps the moon circling around us and keeps our Earth doing its dance around the sun. Now let's get to the most important part of this chapter. This is the big one, Newton's universal law of gravitation. Think of this as the master rule that explains how all of this works. The most important word on this slide is every. Yes, every single object. You and your phone right now, your school bag and the bench it's on. Even you and me through this screen. The biggest stars and the tiniest specks of dust, they're all pulling on each other, all the time. Kind of mind-blowing when you think about it, isn't it?
And here is the formula. Now, don't get scared, it looks complicated, but it's actually super friendly. It just says that the force, which we call F, depends on only two main things. The masses of the two objects, we'll call them big M and small m, and d, which is just the distance between them. That's it.
So let's break this down even more. The top part of the formula, m times m, just means that the bigger and heavier the objects are, like say Jupiter and the Sun, the stronger their pull on each other is. And the bottom part, d squared, tells us that as the distance between the objects gets bigger, the force gets weaker, and not just a little weaker, but a lot weaker.
And what about that big G? Well, it's just a number that never changes. It's called the universal gravitational constant. But look at it. Look how incredibly tiny that number is. That's a decimal point with 10 zeros after it before you even get to the 6. This, my friends, is why you don't feel the gravitational pull of your friends sitting right next to you. The force is there, for sure, but it's just too tiny for us to notice because our masses are so small compared to something like a planet.
Okay, next section. So what happens when an object is falling and the only thing pulling on it is gravity? No air pushing back, nothing else getting in the way, just pure, awesome gravity. Well, that, my friends, has a special name. We call it free fall. You see, when an object is in free fall, it doesn't just fall at one speed. It actually accelerates. It goes faster and faster and faster. We give this special acceleration its own little name, small g, or acceleration due to gravity. And g is a very, very important character in our story today.
Now, a really common question I get is, sir, do heavier things fall faster? And the answer is, nope. A famous scientist, Galileo, proved this centuries ago. The story says he went up the Leaning Tower of Pisa and dropped a heavy cannonball in a light wooden ball. And guess what? They hit the ground at the exact same time. The only reason a feather falls slower than a stone in real life is because of air resistance. If you drop them in a vacuum with no air, they would fall together, side by side.
Here on our planet Earth, the value of this special acceleration, g, is about 9.8 meters per second squared. So what does that mean in simple words? It means that for every single second an object is falling, its speed increases by 9.8 meters per second. So after 1 second, it's moving at 9.8. After 2 seconds, it's at 19.6, and so on. It's like gravity is pushing down on a car's accelerator and never letting go.
All right, let's clear up something that confuses so many students. Mass versus weight. You might think they're the same thing, but they are totally different. And I promise you, by the end of this section, you're going to be an absolute expert on this.
So, here's the most important difference. Mass is simply the amount of stuff you are made of.
We measure it in kilograms, and your mass is always constant, no matter where you go in the universe. Your weight, on the other hand, is the force of gravity pulling on all that stuff. We measure it in newtons, and it changes depending on how strong the gravity is.
Just look at this astronaut. Here on Earth, his weight is 980 newtons. But if he takes that same weighing scale to the moon, where gravity is much weaker, about 1/6 as strong, his weight is only 163 newtons. He feels way lighter. But has the astronaut himself changed? No. His mass, the amount of stuff he's made of, is exactly the same. Only his weight is different.
Now for our next puzzle. Why does a gigantic ship made of tons and tons of iron float so easily, but a tiny little iron nail sinks straight to the bottom? Well, it all comes down to a battle between two forces, gravity, which is pulling down, and another secret force that's pushing up.
And the hero of this upward force is Archimedes. You've probably heard the story of him shouting Eureka in his bathtub. He realized that when you put something in a fluid, like water, the water actually pushes back with an upward force. We call this force buoyancy. It's like the water is trying to lift the object up to help it out.
So who wins this battle between gravity and buoyancy? The secret ingredient is density. If an object, like an iron nail, is denser than water, then gravity's downward pull is much stronger than the water's upward push, so it sinks. But if an object, like a piece of cork, is less dense than water, then the upward push of buoyancy is stronger than gravity's pull, and poof, it just bobs right up to the surface and floats. It's as simple as that.
Okay, bacho, focus time. Let's get you all powered up for your exams. Understanding the concepts is amazing, but getting good marks is also important, है ना? So let's put what we've learned into practice and solve a typical question, just like one you might get in your exam.
First things first, maybe take a quick screenshot of this slide. These are the golden formulas for this chapter. You absolutely need to know them, especially the first two. They're super important. F equals G mm by d squared, and weight equals mass times G. Just learn these by heart, okay?
All right, here is a very common type of exam question. The mass of an object is 10 kilograms. What is its weight on the Earth? And they've even given us the value of G as 9.8. So how do we solve this? It is super easy. Watch this.
Always follow these simple steps. Step 1, write down the formula W equals m times G. Step 2, put in the values you know. So 10 for m and 9.8 for G. Step 3, do the simple calculation. 10 times 9.8 is just 98. And step 4, the most important part, write the final answer with the correct unit. Weight is a force, so the unit is newtons, or just N. See? Full marks. Just like that.
And just like that, we have revised the entire chapter. Wow! But before I go, I'll leave you with this final thought. We know gravity holds our solar system together. But what about entire galaxies, with billions and billions of stars all flying around at incredible speeds? What powerful cosmic glue is holding them all together and stopping them from just scattering all over space? It's a huge mystery that scientists are still trying to solve. So have a think about it. If this explainer helped you, please do like, share, and subscribe. And please leave your doubts in the comments below. I read every single one. All the very best for your exams. Bye-bye.